So we're going to talk about multicolor flame demonstration. This is one that we looked at in class. It's going to be similar in principle to what we talked about last week with luminol, where luminol, the blue glow of luminol, resulted from a chemical oxidation of luminol by hydrogen peroxide, and that caused the electrons to be moved to what we said would be the excited state, or a higher orbital. And then when those electrons came back down to the ground state, the excess energy was given off in the form of that blue light. The particular color blue was only because of the energy levels in luminol. So today what we're going to do is we're going to look at a demonstration where we inject or we spray some metal ions into a flame. And unlike the luminol reaction, where we were looking at the chemical reaction itself producing the excited state, here the excited state is going to come from the energy from the flame. But before we do that, we ought to talk a little bit about fire. And so fire requires three different things. It requires a fuel. So it needs something that's going to burn. It requires an oxidizer. And so something that's going to oxidize that species. In our case, we're doing this out in the air, so it's going to be oxygen. And then it requires the third thing, and the third thing is it requires an ignition source, something that provides energy, a spark to get the particular reaction to go. If you take away any of those things, the fire will no longer go. It would be extinguished. So if we removed all the oxygen from a flame, the fire would go out. If we would put water on it, and the water would absorb all the heat from the flame would go out. And so it explains a couple common ways that you can extinguish a fire and why that might be the case. Now the fuel, it's hard to get rid of the fuel. You really have to do that preventatively. And oftentimes you can't remove the wood from a house if it's burning. So normally you would either take away the oxidizer or you would take away cool it down or take some of the energy or the heat source away. So there are a couple different types of flames that you might run into, and we're going to use this little butane torch to understand this. So I'm going to let the butane go and turn it on, and you probably can't see right now. It is what we'd call a very lean flame. Lean flames are where complete combustion occurs. Very little soot or anything is produced. And so the lean flame is very blue and very, very hot. And the other type of flame that you might run into is one where the oxidizer has been cut back, or the combustion, for some reason the combination of the properties of flame or of the environmental conditions of flame have been altered such that you can't get that same complete combustion. So we would call that a diffusional type flame. That's what you're normally more used to seeing, is that orangish type flame. And you might not be able to see it here very well. We'll look at it. I'm going to come back out in the dark a little bit later. But that sometimes you call that a pre-mixed flame versus a diffusional flame, where the pre-mixed one is where the oxidizer and the fuel are mixed together before the combustion occurs. Diffusional flame is one that you would see like with a match, or you would see it with a candle. And so those are the different types of flames. And what we're going to do in this particular demonstration is we are going to take this flame. We're going to use a nice blue lean flame. Whenever it's dark, you should be able to see that. And I'm literally going to spray a flammable substance, methanol or isopropanol, with some metal ion that's been dissolved in it. It's going to strike or get to that ignition source. There's going to be plenty of oxidizer around. There's going to be plenty of fuel in the alcohol that we're injecting into the flame. Then the flame is going to provide that heat source. That's going to cause the electrons in those metal ions to go to the excited state. When they come back down to the ground state, they will give off, or they will emit a certain particular color of light. We call that atomic emission. And so we're going to see that, and the color that will be emitted will be dependent on the type of metal metal ion that we're going to use. So we're going to see things like strontium and potassium. We'll see boron in boric acid, and we'll get to see there will be different colors that will be emitted. So whenever it gets a little bit darker, we'll go ahead and do that. But for now, we'll just see you whenever it gets dark. All right, so the sun's gone down a little bit. Time for us to go ahead and do the actual experiment where we can see this atomic emission from these metal ions as we inject those or spray them into a flame. And we're going to start with a nice blue lean flame that we talked about. So complete combustion, very, very hot. We certainly want to be very careful to make sure that we stay away from the flame. All right. Also, this is something you can't do on your own. You know, these solvents are very flammable, and we have to be very, very careful about doing an experiment like this. So what we're going to do is we're going to work from the more energetic side of the spectrum down to the less energetic side, and we're going to start with green. We're going to use boric acid, and we're going to spray boric acid in methanol into this flame, and you should see a green color resulting from the excitation of the electrons in the boron. So here we go. Now we'll move on to a yellow or an orangish color. That comes from sodium chloride. That's just plain table salt dissolved in methanol. And it'll produce a really bright, brilliant orange color. It's really intense, more intense than the green that we see from the boric acid. We're going to then move on to the red. We've got two different pigments that are used in red. And you know, before we go any further, you might think about, okay, how would this ever be used? But if you've ever seen fireworks, this is exactly the same type of chemistry that would color a firework. And so lithium and strontium was what would be used as red. So we're going to see lithium next. And then strontium's even more intense. It's probably the most intense of the ions that we see, maybe close to what sodium provides, but provides a brilliant red color. And it just depends on what ion you use, what color you're gonna end up getting. So that's the multicolor flame. So for now, we'll be done, and next week we're going to look at another type of flame type experiment. We're going to look at the whoosh bottle.